while I'm waiting, someone else starts sending, right? So that one finishes, now someone else starts sending. Well, when that message is sent, here's what I will do. With Ethernet, I would just wait until everyone's done and then try. We don't do that here. We back off ahead of time so that we won't have a collision. That's a collision avoidance. How do I know how long I should wait so that I don't conflict with this guy who's sending a message right now? Well, 802.11 frames add something very special. They add a duration. We'll look a little more at this duration here in a second, but basically it tells me how long to wait. It's going to give me a value in terms of slots, all right? So the slots are essentially the number of countdown periods to wait for. I'm doing this countdown. Do I wait? And again, it might be 1 millisecond per time slot, or it could be the slot times could be 2 milliseconds, right? It just depends on the network and how we're working with it. But the point is we're counting down the number of slot times to go through. I started off with a certain value based upon my diffs. I've worked my day down to a certain level. In this case, the duration, it says it's going to take 24 slot times in order to send this message. All right, I won't be done. This message communication process will not be done for 24 slot timers. So that tells you everyone in an area is using the same definition of a nav. That's one of the things you learn when you connect up. So this nav, called a network allocation vector, my value for wait time, my back off counter, is going to be adjusted. See, I'd count it down, 31, 30, 29, 28. I'd gotten all the way down to 18. Then somebody sends a message. I hear that message because remember, messages go out into the air. We all hear it, right? And so because of that, I learn, as this device is talking to the access point, that I better wait an additional 24. So I create a new value for my counter. I ratchet it all the way up to 42. The 18 I had left from my diffs plus 24. And so I keep counting down. 42, 41, 40, right? 24 of that will account for the time that it takes for that frame to be sent. And great. So now we get down to 0. Yay! I got all the way down to 0. So I'll validate that when the countdown has reached 0, the medium is free, right? That's what it means. So I will send out my frame. My frame will include, of course, the duration, just like that other guy's did. How do I calculate that duration? Well, it's based upon 3 values coming together. How big is the frame? A tiny little frame like a DNS frame versus I'm downloading an ISO, so I've got these large frames, full 1,500 bytes if I'm using standard Ethernet for the data, plus the extra header information to get us filled out there, whatever that might be. Plus, we're not done yet, the time to send, the duration, is also going to include what's called a short interframe space, because and the space required for an acknowledgement. So the CIFS and the ACK, essentially what I know is I'm going to send a message, and every successful message over a wireless network, over 802.11, triggers a layer 2 ACK, an acknowledgement of receipt. And so what we see is actually when the access point receives a message, it waits one short interframe space, right? So it doesn't wait the full normal timer, waits this really short timer, because everyone else is going to be quiet anyway. So I'm just waiting the short timer just to give a little bit of buffer here. And then I have this predefined ACK message that goes straight back to that device, right? Referencing that device's MAC address. So that message goes back. Meanwhile, everyone else is waiting because they knew from their own diffs and from the extension, right? So if they had wanted to send something and they were counting down, right? So 30, 29, 28, then that communication occurred. Well, then they got that duration. They added 20, and so they got to 48, and so they did 48, 47. And so that's them waiting their diffs before sending, and then adjusting the nav, the network allocation vector, to include the extra duration that it takes for frames that are occurring. One way to think of it, gang, is like if you're waiting in line for Santa Claus, right? Line of parents and a line of kids, all really tired and cranky, and you would love to be able to just jump right in there and put your kid on Santa's lap. But you can't. You got to wait in line. You're counting down, right? Next, next, next. However, not only do you have to deal with that, but for each one of those communications of someone who's in front of you, you've got to wait however long it takes for them to sit on Santa's lap. Right? So you got to wait for those kids to be done. And if some of them have a long list of things they want for for Christmas, that's going to add to that overall value. But eventually, you get to the front of the line, your kid gets to sit on Santa's lap, everybody's happy, goes home, has some lunch. Life is good. This is the way 802.11 works to manage frames. Remember, it's a half duplex communication that avoids collisions in the first place by having these back-off timers called a network allocation value that's comprised of the distributed interframe space, the basic counter, plus that counter gets bumped up whenever there's frames that get ahead of you that are earlier than you in line, because we need to wait for their duration to complete, which is based upon the frame size plus the acknowledgement plus a short interframe space, which is just a small buffer in between there. That's it. That's how wireless functions constantly. Now, is there a fair amount of overhead involved in this? Yeah, there actually is, and extra gaps in space, but it avoids collisions, because you know what's worse than all this extra waiting? Collisions. Because if there is a collision, then you can have additional problems. Now, one thing to watch out for, it is potentially possible to still have collisions, because I could have a device that's within the range of this access point, and I could have a device that's within the range of this access point, but these two devices don't hear each other's noise. All right, so it is possible that that will happen. And if we have that occur, then we're going to have broken frames, essentially, just because of the collision that happens over the air. And we may be able to interpret some of it anyway, because of the based upon the chipping code that was used. But best, if worse comes, if we don't get an acknowledgement, then we know we need to try again. And again, we will, at that point, back off and then try to submit it again.